consider this mixed divider where we're going to be using our Euclidean geometry theorems that we learned in the previous videos. So this will really summarize everything that we predominantly learned. So this is a good stepping stone to test whether you've grasped all the 6 fundamental theorems that we learned. So after this, you should be able to gauge whether you're getting the concepts or not. So let's say we're given this diagram. We're told that QS is the diameter of the circle at center O, and QR is equal to RT, and T is equal to 35 degrees. So what we need to do is just annotate our diagrams so that we know for sure what we're working with. So we know that Q, P, S, and R lie on the circumference. So we know that PQ, RS, we know that this will be a cyclic quad. So we can just say it's CQ, all right, cyclic quad. And we know that QOS is the diameter. So any angle facing the diameter will be 90 degrees because R1 is facing the diameter, and also the sum of P1 and P2 is also facing the diameter, which will be 90 degrees, right? Which makes sense because PQRS is a cyclic quad, so these opposite angles do add up to 180, which is 90 plus 90. But let's not get besides ourselves and start really looking at the questions that they're asking us. Before we proceed, also observe that since O is the center, we know that OQ will be the radius, which will also be equals to OP, which is the radius, and OS, which is also a radius. So I think we've annotated this diagram enough, and I think we can continue and try to answer the calculate with the reasons the sizes of R2. So we're trying to find what R2 is. R2 is this angle really over here. How do we find angle R2? So we find angle R2 firstly by finding what angle R1 is. We go about and say angle R1 is equals to 90 degrees. And we said the reason for that is that it's an angle in a semicircle or an angle facing the diameter. So which means that R1 is equals to 90. So if R1 is equals to 90, what is angle R2? It's also equals to 90 degrees, because when you add angle R1 plus angle R2, you should get 180 degrees, and that's angles in a straight line. So therefore, we know that angle R2 is equals to 90 degrees. So I've calculated what angle R2 is. We can move on, try and calculate the next angle S2. We need to find what angle S2 is. So angle S2 is there. So if we look at triangle R, S, and T, we see that it's a right angle triangle. So we can safely say angle S2 plus angle R2 plus 35 equals to 180 degrees. And the reason, sum of angles in a triangle give us 180. So we're looking for angle S2, and R2 is 90 degrees. We've calculated that. 35 degrees is equals to 180 degrees. So we isolate S2 and we take everything to the right hand side where they will change signs. So S2 simply equals to 180 minus 90 minus 35, which gives us 55 degrees. So we calculated what S2 is. And let's move on to something even more interesting, which is angle Q1. So how do we calculate angle Q1? Go back to our diagram and analyze this diagram even closer. Earlier on, we mentioned that PQRS is a cyclic quad. If you look closely, if this is a cyclic quad, it means this angle here, Q1 plus 35, should be equals to angle on the outside, the exterior angle. And remember, we said the exterior angle is equals to the interior opposite angle. Exterior angle of a cyclic quad is equals to the interior opposite, which means then the sum of angle Q1 plus 35 will be equals to angle S2. The reason, exterior angle cyclic quad is equals to the interior opposite angle. And we're calculating what Q1 is. So it will be, we know what S2 is. We said S2 is 5 degrees. We subtract 35. Therefore, angle Q1 is equals to 20 degrees. So Q1 is 20 degrees. So we calculate what Q1 is. Let's move on to try and calculate what angle P1 is. So for angle P1, I have to really look closely. This is P1 over there. We know that this is O. O1, we know that PO or OP is equals to OQ. And we just calculated this is equals to 20 degrees. Right? And this is side Q. I just tried to remove that diagram to something a bit more visible here. So if this is our triangle POQ, we have opposite sides PO and OQ that are equal. We know that this is an isosceles triangle because the properties of an isosceles triangle, opposite sides are equal. And if the opposite sides are equal, we know that the base angles will also be equal, which means then angle P1 will be equals to angle Q1, which is equals to 20 degrees. And our reason for that will be equal angles opposite equal sides. And that will be our Q1.